The next section we're going to look at are using simple equations. Very important section for us in looking at these. This is kind of like the introduction to algebraic expressions. Algebra. I had a roommate in college that said he understood math until they started throwing all those letters in there. And as long as you remember that all a letter is, as he put it, is just a variable, which means it can change. It's not constant. It will be, in one particular problem, it will equal this. In another problem, it will equal something different. That's the only thing that's important about a variable. And now we're going to look at some different things. We're going to have an algebraic expression. And then we're going to have the translation of what that means. This is called an algebraic expression, 3x. That means 3 times a number. You will see word problems at times that will say 3 times a number. That means 3x, or vice versa. We have another expression, is 5p minus 3. That means 5 times a number. And then subtract 3, minus 3. You could also hear 3 less than 5 times a number, or 3 subtracted from 5 times a number. These are different ways that you will hear in word problems. They want you to translate these words that we use in English into algebraic expressions. We have m over 7. Now I've intentionally used different variables because whatever letter you have in the alphabet you can use as a variable as long as you're careful. You can use your initials, whatever you want. It'll always work. Just use the same one. Typically it is x's, but it can be all types of different things. M divided by 7 means, just like I said, m divided by, or a number divided by 7. It could also be written as the quotient of, and here's what I talked about earlier, it's very important, m and 7. If you were to write the quotient of 7 and m, that would be wrong. Because the quotient of 7 and m would be 7 over m. Remember, whatever number or variable is first has to go into the numerator. Now let's actually do some different problems using these variables. As I mentioned before, a variable is something that can change. A constant is something that is always the same. 5, 12, negative 13. Those numbers are considered constants. If you were to see a problem that said evaluate 2x plus 5 where x equals 3. Evaluate just means plug it in or find what the answer is. So evaluate is wherever we see an x, we're going to plug in a 3. Because for this particular problem, it is signify that x is going to equal 3. So 2 times 3 plus 5. Well, now we run into BEDMAS again, order of operations. That's why it was so important earlier when we get into these type of problems. We have to multiply first, then we're going to add. 2 times 3 is 6. Then we add and we end up with 11. So when you evaluate 2x plus 5 where x equals 3, the answer is 11. If you evaluate 2x plus 5 where x equals 15, the answer is going to change. The process doesn't change, but the answer is. So you could evaluate this particular expression, it's called. Expression is combination of variables and constants in algebraic form. That's what expressions are. You can evaluate one single expression infinite number of times by using different variables. Now, the most basic thing of algebra is solving for the variable. Very important. If you can't solve these, you won't be able to advance into higher levels of algebra. What we're doing here is we're always doing the opposite operations. What are opposite operations? If they say to add, I'm going to subtract. They ask you to, if they're multiplied, we're going to divide. If they're subtracted, you're going to add. It is whatever the opposite operations are of each other. So addition and subtraction, those are opposites. Multiplication and division, they are opposites also. It's like a light switch. Whatever one they have you do, they want you to undo it by doing the exact opposite. Here, this says a number plus 7 is 10. So we're going to subtract 7 from both sides. 10 minus 7 equals 3. Whatever you do to one side of an equation, you have to do to the other side. You have to keep it balanced. It's like a teeter-totter. If you have people on a teeter-totter and you have 4 people on a teeter-totter and one person gets off, either one person on the other side have to get off, otherwise they're going to go crashing down into the ground. So if I subtract 7 from one side, I have to subtract it from the other. So 7 minus 7 is 0. 10 minus 7 is 3. X equals 3. Well, is that true? Does it work? Does 3 plus 7 equal to 10? Yes, it is. It worked. Now we have x plus 2 is equal to 12. What number plus 2 is equal to 12? Opposite operations here. It's adding 2 here, so I'm going to subtract 2 from both sides. These zero out. X equals 12 minus 2, or 10. X minus 5 is equal to 13. What number, when I subtract 5 from it, is equal to 13? Well, opposite operation of subtraction is addition. So I'm going to add 5 to both sides. These zero out. And 13 plus 5 is 18. 18 minus 5 does equal 13. These are the most basic types of algebraic expressions that you're going to be asked to solve. But there's things that you can do. Also, we've done the opposite operations of addition and subtraction. Now let's try doing the opposite operations of multiplication and division. This particular problem is 5 times a number is equal to 35. 5 times a number. So we said earlier that the opposite operation of multiplication is division. Whatever you do to one side, you have to do to the other side. It's essential. Divide both sides by 5. We end up with 5 divided by 5 is equal to 1x. You don't have to write that 1x in there, but it is fine if you do. And then 35 divided by 5 is equal to 7. So x is equal to 7. Let's look at another one like that. 3x is equal to 27. It's 3 times x. What number times x is equal to 27? Divide both sides by 3, and x equals 9. 9 times 3 does equal 27. Now, a very common mistake, what people will do, is notice we added to 7, or subtracted from 7 from x. We subtracted 2 from x. We added 5, 2x. We divided both sides by 5, but we started with the x. We're always looking at how can we isolate? How can we get the x by itself? So if I have x divided by 3 is equal to 13, I want to know what number when I divide it by 3 is equal to 13. Well, this time it's divided by. The opposite operation of division is multiplication. Whatever I do to one side, I'm going to do to the other side. The only number that will work so that I isolate x, get x by itself, is multiplying 3 times it. Where did I get that number? Right here. If that number was a 7, I would multiply both sides by 7. If I multiply there, those 3's will end up cancel each other out, and I end up with x equals 13 times 3, or 39. So we're never looking to find how can I work with this number? How can I work with this one or this one? It's always looking for how can I get the x by itself, the variable by itself. That's what's important. And the other numbers, they're just along for the ride. They have to, because of keeping things balanced, they get things done, multiplied, added, subtracted to them or from them in order to keep things balanced. So we never look at these numbers over here on the other side of the equal sign to try to figure out how we're going to solve. We always look at x. What do I need to do to get x by itself?